This is lesson 24 on 7-segment displays. Now the Nexus 2 board and the Basis board have 4 7-segment displays shown here. Here's a blow-up of them. And each 7-segment displays has 7 of these LEDs around here plus a decimal point. These are going to be labeled A, B, C, D, E, F, G, and you can light up any one of them to form whatever character you want. Now the way an LED works, here's the symbol for it. If you run current through in this direction, then it gives off light, it lights up. And if you, to do that, of course you make this voltage larger than this voltage. If this voltage is greater than or equal to the plus voltage, then no current goes through. So a diode is sort of a one-way street that you can use to light up one of these LEDs. Now, so as I mentioned, to turn on the LED, you make V2 greater than V1, in which case current goes through. You'll need a little current limiting resistor here. And if V2 is less than or equal to V1, then no current goes through and you get no light. Now 7-segment displays come in 2 flavors, so-called common anode and common cathode. Common anode, the anodes are tied together. This side of the LED symbol is called an anode. And for a common cathode, this side with a little bar in it is called the cathode side. Those are connected together, normally connected to ground. So to turn on a common cathode, you'd put plus voltages in A, B, C, D, E, F, G. They're shown over here. To turn on a common anode, you would set the common anode side to some positive voltage, 3.3 volts in the case of the Nexus 2 board. And the Nexus 2 board actually has a common anode, a type of 7-segment display, in which case you need to bring A, B, C, D, E, F, G to ground, or put a 0 in here, so that the current will flow down through the LED. So to turn on a common anode, you turn it on with a 0. To turn on a common cathode, you'd turn on with a 1. So ours are going to be common anodes. So let's see how we can do it. A 0 is going to turn it on, and so let's figure out how to make all of the 16 hex digits. We'll start with a 0. A 0, of course, we want to turn them all on and turn G off. So to turn G off, we put a 1 here and a 0 on all the rest, A, B, C, D, E, F, G. So that'll make a 0. So to make a 1, what would you turn on? Yeah, B and C. So we turn on B and C with 0, so that makes a 1. A 2 would look like this, so we want to turn off F and C. So we turn on F and C by putting 1s there. To make a 3, we need to turn off F and E. So F and E turn off for 3. How about a 4? Well, a 4, we will make a 4 by turning off A, D, and E. D and E. So a 4 is going to look like this. We turn off A, turn off D and E. So that's going to be a 4. 5 sort of looks like an S. We'll turn off B and E. Now a 6, we're going to only turn off B. So a 6 we will make like this, including the A up here. So we'll only turn off B for a 6. 7 is easy. We'll turn on A, B, and C. Make those 0s. What about 8? Yeah, 8 we just turn everything on. So all 0s will turn on an 8. How about a 9? Yeah, 9 we'll include the D, and so we'll only turn off the E. Now what about A? A, we just turn off the D. So we turn off the D, we'll have an uppercase A. And what about B? We obviously can't make a uppercase B because that would look like an 8. So we make a lowercase b by turning off A and B, putting 1s on A and B. So that's a lowercase b. C, we just turn off B, G, and C, make a C. D, well again, we can't put an uppercase D, it looks like a 0, so we'll make a lowercase d, like this, by turning off A and F. So A and F are off. E will be uppercase, everything except B and C are on. And finally F, make an F, we'll turn off B, C, and D, and we have an uppercase F. So we now have a truth table where the input's going to be this hex digit, 0 to F, and then we'll have 7 outputs, A, B, C, D, E, F, G, and we need to see how to make logic equations so we can implement some sort of a 7-segment decoder. We'll do that in the next lesson.